Last section, not quite like the quizzes we did, but it's still the same idea. We have to try to figure out the identity of an unknown sample based on two things, its density and its specific heat. So first, power through the density part of it. Density is pretty darn easy. Density equals mass over volume. So when I read about this, they had an unknown sample and it was 8.5 grams. And then they did water displacement. We've talked about water displacement. If you take a sample, throw it into a graduated cylinder, and the level goes up, however much it changes, the level changes, that's our volume. So it went from 20 milliliters to 38.7, which is a change of 18.7 milliliters. 8.5 divided by 18.7, 0.45 grams per milliliter. Crucial to put those units, just so that, we're not confusing people. The next part, place the metal in a boiling water bath until it's temp stabilized. They prepared a calorimeter with 38 grams of water at 25. I could go and do this. They said 38 grams. They said it's at 25 degrees Celsius to start with. This, they didn't tell us, but I know that boiling water it's a boiling water bath, so it's 100 degrees Celsius, boiling water bath. When we're all done, the final temp is 28.2. 28.2 degrees Celsius final. This is initial. So all these different things here, and how many grams of that? I think I said it was 8.5. 8.5 grams. Okay, so that's kind of the idea. Same stuff we've been going through. So the way to approach this is it's really two problems. First, I have to deal with something I know a lot about, which is water. Then I'll deal with something that I'm trying to figure out, the specific heat of the metal. Formula we're using is Q equals M times C times delta T. It just told me that I had, let's see, how much water? 33 grams. It's liquid water, 4.18 joules per gram degree Celsius. The change in temp of the water only changed from 25 to 28.2. That's a 3.2 degree change. So when I put that into the calculator, 33 times 4.18 times 3.2, that water gained 441 joules of energy, because grams and grams, degrees Celsius, they all crossed off. Where'd it come from? Well, the only thing that was changed was lost my metal, there it is, was the metal that was added. So apparently all the heat that the water gained came from the metal. How do we know it didn't come from the rest of the environment? Well, we put it into a styrofoam insulated container to make sure that it didn't get contaminated by outside energy. So if the water gained 441 joules, that means that the metal lost 441 joules. 441 joules from the metal. How much metal? 8.5 grams. I'm going to set it up just like the Q equals MC delta T formula. What's the specific heat? That's what I'm trying to figure out. What was the change in temp? The most often missed thing of the metal. The metal started at 100, ended up at 28.2, because that's where it stabilized. 100 minus 28.2 equals 71.8. And I'll put 71.8 degrees Celsius. If I want C by itself, I got to divide by 8.5 and divide by 71.8. That and that cross off. But what I do to one side, I have to do to the other. 8.5 grams, 71.8 degrees Celsius. 441 divided by 8.5. Also divided by 71.8. No need for parentheses if I do that correctly. And I will get 0.72 joules per gram degree Celsius. This one didn't happen to have a little matching thing to to compare it to, but I'd be able to go to a chart and see if I could line up which one matched.